For the first time, neuroscientists and medical professionals were able to detect chronic pain from human patients using intracranial neural biomarkers. The study was published a few weeks ago. I have a video to show you that talks about it, and then I'd like to go a little bit more in depth in the paper itself. And finally, I have a video for you that talks about the association between chronic anxiety and chronic pain. I'm Cameron, and this is my channel. Welcome to the Sexy Universe.
All the stars in the sky, all the lights on the highway. Oh, they keep us coming alive.
Direct neural recordings were just used to examine chronic pain in patients with neurological damage. It's the first time it's been done, and I'd like to talk about it. The study is part of a larger project to see if direct brain stimulation can be used to relieve chronic pain. Chronic pain is pain that goes on for weeks, months, maybe even years, and it can be caused by diseases such as cancer or injuries, but it can also last long after the initial injury is over. According to the CDC, more than 20% of American adults can be affected by chronic pain in any given year. Indigenous Americans and bisexual Americans are disproportionately affected by it. And a really disturbing number is this 7% who experience high impact chronic pain. And that's the really debilitating kind of pain that can go on for months or years. And it can become part of a cycle that leads to insomnia, anxiety, depression, and addiction. There's also an association with dementia, though we don't know which direction the causation goes. Previous studies used fMRI machines to look at different parts of the brain, but part of the problem with an MRI is the patient is stuck in there. They can't move, and so it can't be part of their regular life. But it did allow researchers to identify parts of the brain that really are closely associated with chronic pain, like the anterior cingulate cortex. Shout out to Barnes & Noble. This is their edition of Gray's Anatomy, the old school version. In the yellowish green here, I've outlined the anterior cingulate cortex. And in this study, they also looked at the orbital frontal cortex. This is actually a brain that's been sawed in half. You can't see this part from the outside, but actually you can see the orbital frontal cortex from the outside of the brain. So they used this machine, which was actually developed to treat Parkinson's using direct brain stimulation. And these are the leads they installed in the patient's brains. These leads are actually about a little less than a millimeter in size. The first patient was a woman with pain on one side due to a stroke. Second patient was a man also suffering from stroke. The third was a woman who had experienced amputation. And the fourth was a man also with stroke pain. So this image shows where they installed the leads. The little red dots are the leads. And here's another cool image of all that. And basically, by comparing the two sets of readings from those parts of the brain, they were able to detect when the patients experienced chronic pain. They just couldn't tell how bad it was. But it's a start. You can see this article is from Nature Neuroscience, published on May 22nd. And there are just a few things in this paper I'm going to go over real quick. Part of the way patients were chosen for this study was they looked at people who had neuropathic pain, where it's pain that's caused by damage to the nervous system. And one problem with understanding chronic pain and developing treatments for it is that we don't even know how the brain translates it. One thing they point out here is that chronic pain naturally varies over time. So sometimes it's felt intensely and sometimes not. They point out that the anterior cingulate cortex, its role in sensing acute pain has been well characterized. But the role of the orbitofrontal cortex really hasn't been studied all that well. But it's heavily connected to other parts of the brain that are associated with pain sensations. And basically, with the way they did this, this was the first time that they were able to put these kind of instruments in patients and use them to measure chronic pain. They did try to predict acute pain, pain in the moment from patients using the readings they got from the anterior cingulate cortex and orbital frontal cortices, but they just weren't able to reliably get it from all patients. There were 2 patients they were able to get enough data to make it useful with, but the other 2, the data was too ambiguous, at least using the analysis they used. And I'm going to get back to talking about their analysis in a moment. The researchers relied on the difference between normalized data from the anterior cingulate cortex and normalized data from the orbital frontal cortex. There are a number of ways to normalize data, but if you need to work with 2 separate data sets and make them comparable to each other so you can either add or subtract them, one of the easiest ways to do that is to norm them all to either 1 or 100 or 10, just some number that's easy to use. And I wasn't able to find precisely the equations they used to normalize their data, but I suspect it was something like this. So what they found was that orbital readings from the orbital frontal cortex were more valuable for understanding pain when it was either bad or good, either high pain or low pain. And they specifically said the contralateral orbital frontal cortex, which actually means the portion of it that extends all the way across the brain from left to right. And here's a little video. You can see in the green where it shows the contralateral orbital frontal cortex as you travel through the brain. They also found that brain activity shifted to the anterior cingulate cortex when there was some acute pain that was sensed. And again, here is the graph that shows the difference between high pain readings and low pain readings coming from the sensors. And a couple limitations of their study that they point out is it's a small sample size, and that it's possible that their machine learning models may be looking at other variables than the actual pain sensations that the patients were experiencing. I also think that it may be worth their while to look at changes in noise. For example, the mean and standard deviation of noise in the readings, because very often that noise contains a signal within itself when it's properly analyzed. So that's all I'm going to talk about that particular paper. Now would be a good time, if you're enjoying this, hit the like button, and please leave your thoughts or questions in the comments section. It helps the YouTube algorithm. And next I have a short video about the link between emotional trauma and chronic pain. This comment was part of a string where Lovely Tiff talked about the idea of a possible link between chronic pain and past emotional trauma. This is from an article from PTSD Research Quarterly, put out from the U.S. Department of Veterans Affairs. And in studies they looked at, it looks like anywhere between 25 and 80% of PTSD sufferers also suffer from chronic pain that they don't really know the source of. It doesn't appear to have any physical cause. I also saw this interesting little article from the Institute for Chronic Pain. And I went ahead and checked all the linked studies they had in here, but they point out, among other things, that folks who suffer from fibromyalgia, arthritis, and even lower back pain are much, much more likely to have experienced abuse and neglect in childhood. A couple of these studies pointed out that it didn't even matter what kind of childhood abuse or neglect it was. It all tended to have the same impact. And this also includes migraines. One exception was chronic pelvic pain, specifically in women, was more likely to be associated with sexual abuse. So it's a great string of comments and conversation. Thanks for pointing this out. Thanks for watching my video. If you'd like, you can follow me on Instagram or TikTok at Camwadam, Camwadam. Please like and subscribe, and I will see you next time on The Sexy Universe.